Welcome everybody to our poster. In this work, we propose a novel, simple, but yet powerful semantic segmentation algorithm on style-GAN synthetic images. Different from previous work that solves a similar problem, our method does not need to train an independent masking network, nor does it need human annotation on pixel-wise semantic masks, but it can still produce highly accurate semantic segmentations, and the method is derived from a key observation that the pixels belong to the same semantic class change their color together across different style mixings. Knowing this, semantic segmentation can be simply done by clustering color features across all the style mixings. The proposed method shows comparable results with state-of-the-art unsupervised segmentation on synthetic images, and it can also be served as synthetic annotation sources for downstream training. Now let's talk a little bit more on the details of the work. So the problem we're trying to study in this paper is semantic segmentation on synthetic images. We'll start off by describing our solution for style-GAN 2, and then briefly mention how do we go beyond style-GAN in the later stage of the presentation. Semantic segmentation on style-GAN is really not a new problem. Many work has done it by taking advantage of a rich semantic structure learned in the style-GAN generator, such as dataset GAN, label for free, segmenting style for GAN, and so on. And all the previous method has a common feature is that they use a masking network branch that takes intermediate features of style-GAN generator as input, and then produce output masks. So this is somewhat problematic because for every new generator, the masking branch has to be retrained. In the case of a new generator architecture, the masking branch even has to be redesigned. So, and also due to the high dimensionality of the intermediate features, the previous method often face challenges on GPU memory limitations for high resolution synthetic output. And in this paper, we propose a novel but yet effective and also simple segmentation method that does not need to train an independent masking branch, is unsupervised, so no pixel level human annotation needed, and still highly accurate. We achieve this by deriving from our key observation that in style-GAN and style-GAN 2, pixels that belong to the same semantic class change their color together across different style mixings. To understand it further, let's first talk a little bit background on style mixings in style-GAN 2. So style mixings happen between two latents of the style-GAN, or two latents for the style-GAN generator. Here, latent 0, latent 1, and it happens in the W plus representation space of the latent. That is right after the mapping network, and then replicated for the synthesis network's input. So you will see multiple layers or multiple vectors of the latents in the W plus space. And if we say we want to preserve the structure of the first image and first latent and the style of the second image, what we could do is we can define a layer cutoff C, and saying everything before is for structure and everything after C is for style. Then we simply mix the two latents, pass it to style-GAN generator, and generate an image that has the structure of the first one but has the style of the second image. So knowing this, let's recap what we said on the key observation. So in style-GAN 2, pixels that belong to the same semantic class, they change their color together across different style mixes. Okay, so what more specific do we mean? Let's take a look at these four images as an example. And in this four image, we can first extract background pixels. Let's do two patches here, 1 and 2 on the background. And we can do the same for two patches on the closing, and two patches on the face, and two patches on hair. And we can do this. This is just for latent 1, and we can do this for latent 2, latent 3, and latent 4. Okay? And remember 1, 2, 3, 4, 5, 6, and 7, 8, they are each pair corresponding to a different semantic class. So if we group them together, we can somehow notice that for the same object or same semantic class, the color changes across different latents or across different style mixings. They are highly correlated. On the other hand, when the pairs or colors or pixels, they're coming from different groups or different semantic class, their color changes across style mixings is of very low correlation. So this is the key observation that we develop our algorithm upon. And once we know this, the algorithm design is very simple. So if we're given input, our algorithm just have 4 following steps. First, generate n style variants by style mixing in style GAN, for example, or it can be used by other methods. Second, we concatenate all the style variants, get a n by 3 or by c by h by w tensor. N here is the n number of style variants. Then we cluster the pixels. So here is h by w pixels into k clusters by flattening the n by c dimensions. So that is style variant color dimensions. And fourth, we perform a foreground identification heuristic for foreground background class. This algorithm can be extended very easily to object and instant segmentation with the help of a detector. Simply do the detection first in the original image and then run through step 1 to 4 just within the crop. And we can do this because our algorithm is solely operating in the pixel space instead of in the intermediate feature space from style GAN generator. And in the experiment section, we tested the foreground background segmentation test directly on synthetic images and instant segmentation on synthetic images, where we have an advantage in terms of the design, as previous methods find a very hard time to extend to such task. Third, we test on generating synthetic segmentation data for downstream training. And now let's show a little bit more of qualitative results here on faces, on cats, and on wild animals. And here are 2 quick examples on object segmentation as well as the comparison with the previous methods, label for free and segment in style, where you can see the challenge they face on extending to object-specific segmentation. Thank you very much. Please check out our paper and our poster session on Thursday.